By this point, you should have finished solving the right-hand side of the Solving Rational Equations worksheet. I am quickly going to go through the answers, and then I'm going to work through the problems. If you miss them, you need to skip to the portion of the video of the solution method for the problems, because right now I'm just giving solutions and I'm doing it quickly. Number 2, you should have x equals 2. Your restricted values, x cannot equal -5 and x cannot equal 0. For number 4, you should have b equals -2.25 or -2 1/4. There are no restricted values. Number 6, you should have k equals 1/2. K cannot equal -2, nor can it equal 0. Number 8, x equals -2. X cannot equal 2/3 or -2/3. Number 10, a equals 5. I don't know that I wrote the restricted values there. A may not equal 3, and A may not equal -3. And then number 12, K equals -1. K cannot equal 2, nor can K equal 6. Okay, if you got all those correct, great. If you did not, you need to go back through with me. You can skip just to the problems that you need to see. For number 2, you need to find the least common denominator. Actually, this is just a basic proportion, so you can actually use cross products. 1 times 7x is 7x. 2 times the binomial x plus 5. Don't forget those parentheses are important. 7x equals 2x plus 10 minus 2x from both sides, so I have 5x equals 10, x equals 2. Your restricted values, if I set this denominator equal to 0, if x was -5, that would make it 0, so that's not going to work for us. I'm trying to set this up so it's a little bit easier to see. So x cannot equal -5, and x cannot equal 0, so if I set that equal to 0. Number 4, this one does require that we find a least common denominator of 14. So I'm technically going to multiply every single term by 14. Okay, so here's where you got to think through. If I just multiplied this by 2, then I would be good to go because that would be 14. So if you're struggling with how to find a common denominator, you could just think about what would I have to multiply this term by, 2 over 2. This one would be 7 over 7. That's what I'm doing as I'm simplifying this, just so I don't have to show everything. So I'm multiplying this by 2 and multiplying the bottom by 2. That would give me my 14. So it's 2 times 2b minus 3 minus, this would be like having 7 over 7. So minus 7b equals b plus 3. And then technically you're clearing out the denominator. So this would become 4b minus 6 minus 7b equals b plus 3. -3b minus 6 equals b plus 3. I'm going to move the b over, so minus b from both sides. I have -4b minus 6 equals 3. Add 6 to both sides. -4b equals 9. Divide by -4. b equals -2 1/4, or -2.25. And you may use a calculator. And there are no restricted values because there's no variable in the bottom. And technically, that's not even really a rational equation, because if you go back to your definition, you're supposed to have a variable in the denominator. But this is just good to get us to understand how do we find a common denominator and how can we simplify it the easiest. Number 6, you have a binomial, and then you have a plane k. If you think about what their least common multiple is, it's actually the product of the two. So you do need to have everything multiplied by k times k plus 2. So again, you kind of have to figure out what works for you. I'm going to actually show it in more expanded form, just in case anybody's having trouble. So if I multiply this, really, I have to multiply everything by k plus 2 and k. And it's technically over k plus 2 times k. So it's like I'm multiplying by 1. So I'm just going to do what I've been doing. I am multiplying everything times their least common denominator. What it's doing is it's clearing out the denominator. Since this already has a k plus 2 on the bottom, by multiplying it by k plus 2, those would cancel here. But I still have to multiply 5k by k. So I have 5k times k plus, this already has the denominator of k, so those would clear, but I still have to multiply 2 times k plus 2 equals, and then 5 is getting both things, both factors. So this is 5k squared plus 2k plus 4 equals, and then this would be 5k plus 10, or you could do k squared, 5k squared, plus 2k times 5 is plus 10k. I have a 5k squared on both sides. That works out nicely. I'm going to move my 2k over. So I have 4 equals 8k. Divide by 8. Divide by 8. K equals 1/2. So that's my solution. But k cannot equal -2 because that would make that 0. And k cannot equal 0, because that would make that 0. So those are my restricted values. Make sure you're going back into the calculator and checking. For number 8, the least common multiple would be the product of these two binomials. So everything is going to get multiplied by 3x minus 2, 3x plus 2. So if I multiply this term by it, if I have it in my denominator, it clears it out. That's great. We get rid of our fractions. So that clears that. But then I still have to multiply the top by 3x plus 2. So I have 4x, 3x plus 2, plus 2x over 3x plus 2. If I multiply this by this set of binomials being multiplied, these factors, this would clear with that, meaning I'd still have to multiply my numerator by 3x minus 2. So I have 2x times 3x minus 2 equals, and 2 has to get multiplied by everything. I'm actually going to multiply it into the first one. So I have 6x minus 4 times 3x plus 2. All I did was multiply it in, just so I don't have to worry about 3 factors. All right, down to a lot of simplifying here. 12x squared plus 8x plus 6x squared minus 4x equals 18x squared plus, actually I probably should have left it because it would have just been a, oh well, plus 12x minus 12x, see, plus 12x minus 12x, those disappear, and then I have minus 8. Let's see here, I've got 12x plus 6x make 18x squared. 8x minus 4x is 4x equals 18x squared. Ooh, very nice. Those are going to cancel. Minus 8. Cancel, cancel. X equals -2, and I divide by 4. Remember, our restricted values are anything that make the denominator 0. So if I set this equal to 0, add 2 to both sides, divide by 3, so x cannot equal 2/3. Subtract 2 from both sides. -2 divided by 3 is -2/3. So those are your restricted values. Number 10. Again, least common denominator would be a minus 3 times a plus 3. So if you just multiply by those two binomials, those two factors, it'll clear our denominator out entirely. So I'm going to multiply everything by a minus 3, a plus 3. I multiply this term by a minus 3, a plus 3, the denominator a minus 3, and this a minus 3 cancel. So I'm multiplying my numerator by a plus 3. 2a minus 3, a plus 3. Minus 2, and 2 has to get multiplied by everything because it doesn't have a denominator, equals 12 times a plus 3 and a plus 3 will cancel. So that means 12 times a minus 3. Whew. Okay, I've got lots of simplifying again. So I have 2a squared plus 6a, I'm foiling, minus 3a minus 9 minus 2a plus 6. Uh-oh, I just made a mistake, didn't I? Actually, let's think about it this way. Here I have a difference of squares. So I have a squared minus 9 I have to multiply it by 2. So a squared minus 9 is really going to be negative 2a squared. And then it was minus 9 minus 2, so it would really be plus 18. You might have to do that in multiple steps to not make any mistakes. Hopefully I didn't. Nobody's here to correct me. 12a minus 36. Over here I have 2a squared minus 2a squared. So those canceled just right there. And I've got, let's see, 6 minus 3a is 3a. Minus 9 plus 18 is, where am I? Minus 9 plus 18 is plus 9 equals 12a minus 36. Alright, minus 3, or actually I'm just going to minus 12a. So I have negative 9a minus 9 from both sides is negative 45. Divide by negative 9, divide by negative 9, a equals 5. And then my restricted values, a cannot equal 3 and a cannot equal negative 3. Okay, so 12 looks quite awful, but it's actually not that bad. I may have to actually go to a sticky note just because that space is not huge. I'll start here. So if I factor this right here, I'm going to rewrite it entirely. I have k, and then if I multiply 6 and 2, negative 6 and negative 2 make positive 12. Negative 6 and negative 2 add to negative 8. So minus 6, k minus 2 equals k over k minus 2 plus k minus 6. So it's not so bad. I want to clear the denominator, so I'm going to multiply by this entire thing. So I'm multiplying by k minus 6, k minus 2. That clears our entire denominator out over here. So it means I have 4 equals, if I get rid of k minus 2 and k minus 2, those would clear out. So I have k, I still have to multiply by k minus 6, plus, over here the k minus 6's would clear, so plus 1 times k minus 2. Alright, I'm going to go to sticky note, just so I don't squish it too much. So I have 4 equals k squared minus 6k plus k minus 2. I'm going to scoot everything over to one side because it looks like I'm not going to be able to clear out my k squareds like I have in the past. So I have k squared minus 5k minus 4 from over here, so minus 6 equals 0. So my two factors of 6, one's going to have to be positive, one's going to have to be negative, so they'll have to subtract to make 5. So 6 and 1 will do that, and I need more negatives. So I'm going to put the negative with the 6. So k can equal, k could equal negative 1, and k could equal 6. Okay, so this is where checking is kind of important. And really, the reason why is because what are my restricted values? K cannot equal positive 2, and k cannot equal 6. So all of a sudden, there goes one of my restricted values. And that's going to happen whenever you have the squared on the bottom and you have to refactor, and you're left with a k squared. So your actual only solution is k equals negative 1, and then there are your restricted values.